Today we are going to perform two experiments that involve the liberation of gas from solution to make geysers. As a reminder, this is a stereoscopic video, meaning that a VR headset is recommended, including something like the Oculus Quest or a cell phone that is utilizing the Google Cardboard app in a more simplistic headset such as this. Today we are going to perform the experiment most typically known as the elephant toothpaste experiment. Here we are going to utilize a chemical reaction to generate gas that will lead to the dramatic formation of a foam. We are going to take a soapy solution containing hydrogen peroxide, which has a chemical formula of H2O2. Upon the addition of the catalyst potassium iodide, the hydrogen peroxide will break down into water, H2O, and oxygen gas, or O2. The generated oxygen gas escapes from the solution via soap bubbles. The generated bubbles take up a lot of volume and can quickly fill the container. Should the container not be big enough for the large amount of bubbles, the foam can escape, making a geyser. So as you can see in this quick initial demonstration, the foam took a little bit of time to escape owing to the large volume inside the pumpkin cavity. Now in the next experiments, we will switch to more restricted gasware to see if we can make a more impressive geyser. As we set up our experiment, we are going to begin with a soap agent. Here we are using a hand soap from the lab to allow the soapy foam to form after gas evolution. We are using a syringe to measure out exactly 5 milliliters to each of the volumetric flasks so that we are uniform. Next, we need to prepare a saturated solution of potassium iodide. Again, potassium iodide is the catalyst that is going to promote the decomposition of hydrogen peroxide into water and oxygen gas. Here we are going to swirl the flask for a few minutes, and then we are going to distribute that solution among 3 different syringes with 5 milliliters of the solution in each syringe. We are now going to prepare hydrogen peroxide solutions in each of the volumetric flasks. We are going to use concentrated hydrogen peroxide, which is around 30% by volume. Here in the first flask, we're going to add 30 milliliters of the hydrogen peroxide, and so that's going to be fully concentrated. In the second flask, we are only adding 15 milliliters of hydrogen peroxide and 15 milliliters of water, so it's going to be half as concentrated. In the final flask, we're only adding 5 milliliters of the hydrogen peroxide and 25 milliliters of the water solution. And finally, we are now going to test the hypothesis that the more highly concentrated hydrogen peroxide solution will evolve more gas and therefore create more foam. We are now adding the 5 milliliters of the potassium iodide solution to each of the flasks. Well, you'll notice the left flask that contains 5% of hydrogen peroxide gave a much smaller response than that of the 15% hydrogen peroxide solution in the middle, and finally the 30% containing flask on the far right. This shows that the more hydrogen peroxide in the flask leads to a larger response and greater oxygen evolution. And okay, before we set up this experiment, I just wanted to point out a couple differences between this experiment and the one we just did with the elephant toothpaste. In this experiment, we are going to take a liquid that already has dissolved carbon dioxide in it. When we add Mentos, there is going to be a liberation of that dissolved carbon dioxide into gaseous carbon dioxide. And the way that this happens is a physical process where all of the dissolved carbon dioxide interacts with the surface of those Mentos that has all these nooks and crannies, which is a perfect surface to allow the nucleation and the enlargement of carbon dioxide bubbles. And those bubbles get larger and larger, and as they get larger and larger, they foam and explode out of that bottle. Okay, we're ready to try it. We're going to go ahead and put that open. Alright, who wants to hold this? Okay. Hold this right here. Can you put it on top? Got a good bottle? Right, hold up. Alright, we're going to put this, alright, like this.
I don't want to reach.
Okay, hold up. Alright, you ready? Alright. Here we go. You ready to go? Here we go. 1, 2, 3. What? Oh.
Can we touch it?
Yeah?
Can we touch it?
You can drink it. Oh, it's done.
Hmm.
Ours wasn't quite the geyser
Well, can we,
that we've seen online.
Can we spray?
Okay, well now we're going to try it on a carbonated keg of just sparkling water. Let's see if we can get this to work. So, let me release some of this gas. Alright, ready? So I got some more Mentos. This is already fizzing a lot. Alright, here we go. You guys ready? Here we go.
Is that beer? What is it?
That's water.
Can we drink it?
Alright.
Can we drink it?
Well, you can drink that because it's just water. Alright, so that was our experiment with a little bit more water.